guys, welcome back to the channel. We're back for part 3 of the oscilloscope. We left off on page 40. So we'll get started. Page 40 talks about parameter setting method. It says for parameters with the line displayed on the menu, you can turn the multifunction knob directly to set desired values. For the parameters with the arrow down displayed on the menu, press down the multifunction knob and the numeric keyboard is shown in the figure below displayed. Turn the knob to select the desired value and press down the knob to input the value. After entering all the values, turn the knob and select the desired unit and press down the knob to complete the parameter setting. So that's going to be an operation menu, I believe. So I'm not real sure on that one. Oh, okay. It's saying the multifunction knob. This can be used to modify the parameters. So that one's not very clear, but it's just saying, I guess you could use the knob as a way to change the parameters. Anyway, okay, moving on. To use the security lock, if needed, you can use this security lock. Please buy it yourself to lock the oscilloscope to a fixed location. The method is as follows. Align the lock with the lock hole and plug it in the lock hole vertically. Turn the key clockwise to lock the oscilloscope and then pull the key out. So, if you remember the back panel I showed you, there's a way to lock the oscilloscope on the back. Let me lift it up and I'll show you again. This is the lock hole, so this is what it says. You align the lock with the lock hole, you plug it in, you lock it vertically, and then you turn the key clockwise and take the key out. Okay. To use the built-in help system. The help system of the oscilloscope provides instructions for all the function keys, including the menu keys, on the front panel. Press help to open the help interface and press again to close the interface. The help interface mainly consists of two parts. The left are help options and the right is the display area. So let's press the help. Okay, so the left is the help options, and the right is the help display. I'll zoom in. Okay. You can press the button except for the power key, the multifunction knob, and the menu page up and down key directly on the front panel to get the corresponding help information in the help display area. So let's see if, okay, so you use the multifunction knob, which is the intensity knob. And let's get, how about, how about run stop? Let's click that one. Oops, we clicked utility. It says this button can start or stop the waveform sampling function. In the running status, this button is illuminated with yellow and the screen displays the run cue in the higher left portion. The button is illuminated with red in stopped status and the screen displays stop in the higher left position. So if you don't have the manual, you can go through this and it will tell you. Measure F1. Vmax, maximum is the highest value in the waveform display. The picture shows the values being measured. Vmin, the minimum is the lowest value in the waveform display. The picture shows the values being measured. Volt, peak to peak. Value is the difference between maximum and minimum. The picture shows the values being measured. Volt top, the top of the waveform is the upper part of the waveform. The base of a waveform is the lower part of the waveform. The picture shows the values being measured. Alright. We're on Chapter 2, to set the vertical system. Contents of this chapter. To enable the analog channel, channel coupling, bandwidth limit, probe ratio, waveform invert, vertical scale, amplitude unit, channel label, delay calibration of the analog channel. To enable the analog channel, the oscilloscope provides two analog input channels, channel 1 and channel 2. As the setting methods of the vertical systems of the two channels are the same, this chapter takes channel 1 as an example to illustrate the setting method of the vertical system. Connect a signal to the channel connector of channel 1 and then press channel 1 in the vertical control area on the front panel to enable channel 1. So I'm going to exit out of help. So I just press the help key again. Okay. Okay, I guess we can connect a signal. Let's see. I'm going to set up my breadboard here with a signal. I'm just grabbing it here. So I've got a signal generator that I made actually, and I'll zoom out, trying to get it. So I've got this I-5351, and it's a signal generator circuit, and I've got it hooked up to an ESP32, and I marked on there what frequency I'm attempting to generate, but I haven't really been able to measure this yet because I haven't been able to get a good read on it, so I'm going to plug it in. Okay, and I'm going to put it on my breadboard so I can get a better reading. Okay. Actually, I need more pins to do that, so one moment. Let me get it set up and I'll meet you back here. Okay, I finally got it. It's been hard to get a measurement on this one because it's so finicky, but I'll show you my setup over here. So you can see the breadboard. I'll try to move it a little closer. Okay, so I've got the ESP32 set up to the signal generator, and I've got, I know it looks like spaghetti. Okay, I've got, this one is a VIN, which goes to the power, which goes to the VIN on this one. And I've got a ground, and the ground goes ground to the ground on this one. Then I've got another ground, which is this red, to the ground of the breadboard. And then I've got clock 1 to clock 1 on this one, and then clock 2 to clock 2 on this one. And the way this chip is set up is that you can put it on this one, number 1, and it'll allow you to visualize the output. So I've got a piece of copper wire stuck in the breadboard right next to that pin to pick up the output, and then I've got a copper wire stuck in the ground over here to get a good ground, because if you don't get a good ground, you're not going to see the signal. That's been my problem. And you can see the signal on the screen. This is what I'm emitting. It's not pretty. But you can see the frequency is like emitting around 5 kilohertz, which I coded it to be 4.6. It has 2 outputs, so I coded it to be around 4.6, so it's not very accurate, but it's close. So let's see if we can use this as our signal output for learning purposes. Okay, let me just take a drink. Okay, so back to the manual. We're hooked up to our signal on our probe, and it says connect a signal to the channel connector channel 1, and then press channel 1 in the vertical control area. So we already have ours connected to channel 1, which is our probe, and then we already have our channel 1 lit up, and channel 1 shows up as a 1 right here in the screen. I don't know if you can see it. It's kind of hard to see, but it has a 1 in the middle of that flag. So it also has a 1 down here, which says 1, channel 1 is 10 millivolts. So that's what we're emitting. Next up, channel coupling. Undesired signals can be filtered out only by setting the coupling mode. For example, the signal under test is a square waveform with deep C offset. When the coupling mode is DC, the DC and AC components of the signal under test can both pass the channel. When the coupling mode is AC, the DC components of the signal under test are blocked. When the coupling mode is ground, the DC and AC components of the signal under test are both blocked. Press channel 1 coupling and use the multifunction knob to select desired coupling mode. The default is DC. The current coupling mode is displayed in the channel status label at the bottom of the screen as shown in the figure below. You can also press coupling continuously to switch to the coupling mode. Okay, let's see if we can find that. Press channel 1. Then you press coupling. See, ours is in DC, that's default. We can scroll to AC. Okay, I can't seem to get the signal set up again. I lost it. I had to pause there for a minute and I lost the signal. And now I can't seem to pick it up. I've got everything grounded and plugged in and I can't seem to get it picked up on the oscilloscope in the auto range. So that's frustrating, but we'll continue on to the manual. And I just keep picking up the mains electricity, so that's the main that's the signal from the power in the house. So okay, so we picked up on, just to pick up on where we were on channel 1, we were on DC, and if you go to AC, then that shows the DC components under the signal and test are blocked, and when you're in AC. When you're in ground, DC and AC components are both blocked. Okay, so next up after channel coupling, we have bandwidth limit. The oscilloscope supports the bandwidth limit function, which can reduce the display noise. For example, the signal under test is a pulse with high frequency oscillation. When the bandwidth limit is disabled, the high frequency components of the signal under test can pass the channel. When limiting the bandwidth to 20 MHz, the high frequency components of the signal under test that exceed 20 MHz are attenuated. Press channel 1, then press bandwidth limit continuously to switch the bandwidth limit state. The default is off. So we hit channel 1 to light up, and then we hit bandwidth limit. And you hold it down, and it goes to 20 megahertz. 20 M is 20 megahertz. When the bandwidth limit is enabled, the character B will be displayed in the channel status label at the bottom of the screen. Right there. B. You can see it. Right there. Okay. I'm going to turn it off now. Next up, probe ratio. It says bandwidth limit can reduce the noise as well as attenuate or eliminate high frequency components of the signal. I didn't even look at the signal. I can't really tell a difference in the waveform. Anyway, probe ratio. The oscilloscope allows user to set the probe attenuation ratio manually. Channel 1 probe and use the multifunction knob to select the desired probe ratio. Probe ratio values available are as shown in the table below. So we can change it. Let's change it to 100 times. Okay, let's go 0.01 times. And then back to 10x. Okay, wavefront invert. Press channel 1 invert to turn off the waveform invert. When waveform invert is turned off, the waveform displays normal. When waveform invert is turned on, the waveform voltage values are inverted as shown below. Okay, we're going to turn our invert on right here. So that's the inverted. Okay. Vertical scale refers to the voltage value per grid, the vertical direction on the screen, and usually expressed as volts per division. Press channel 1 and rotate vertical scale to adjust the vertical scale clockwise to reduce the scale and counterclockwise to increase. Okay. Okay, here's the vertical scale over here. So this increases and then that decreases. And then press vertical. The vertical scale can be adjusted in coarse or fine mode. Press channel 1 volts per division to switch the adjustment mode. Coarse adjustment, take counterclockwise as an example. Set the vertical scale in 1 to 2 5-step, namely 10 millivolts per division, 20 millivolts per division, 50 millivolts per division, 100 millivolts per division, and so on. Fine adjustment. Further adjust the vertical scale within a relatively smaller range to improve vertical resolution. If the amplitude of the input waveform is a little bit greater than the full scale under the current scale, and the amplitude would be a little bit lower if the next scale is used, fine adjustment can be used to improve the amplitude of the waveform display to view signal details. So you can use this in conjunction with the scale. So it changes the way your scale works. You can put it back on course, and you can see the scaling button is completely more responsive if it's on course. So that's what that's for. You can press vertical scale to quickly switch between coarse and fine adjustments. So if you press this, it's going to go from fine back to coarse. So that's the quick button. When changing the vertical scale of the analog channel by rotating vertical scale, you can select to expand or compress the waveform around the center or ground. For more details, please refer to the Introduction in Vertical reference. Okay, amplitude unit. Select the amplitude display unit for the current channel. The available units are W, A, V, and U. When the unit is changed, the unit displayed in the channel label will change accordingly. Press channel 1, then unit to select the desired unit, and default is volts. So if we want to change the volts, we can change it to, oops, I forgot, volts, so we can change it to watts. And it says 200 milliwatts. We can change it to amps, 200 milliamps. And back to default. Back to default. It keeps doing that. Okay. And I think I'm going to end it there for the day. And I'll see you back next time for the next oscilloscope overview. Thanks for watching, guys.